All right, in this example, this is the same buffer solution that we were looking at above. So I am going to go ahead and pull out of my hat. You can go back to question 5 if this is confusing to you. The pKa for ammonium is equal to 9.25. Okay, we'll need that here in a minute. But check this problem out. So we have a buffer, and now we're going to take some of that buffer solution. We're going to take 100 mLs of that solution, and we're going to add some strong acid to that solution. So what we need to do for this type of problem is we need to calculate how much of the base that acid will chew up, and in chewing that base up, it converts it into the acidic form. So some amount of ammonia is going to get converted into ammonium. But let's see how much we have to begin with. So N being the number of moles of let's do HCl here first. See how much HCl we're adding. I'm adding 50. I'll go ahead and divide that by 50 by 1,000 to convert that into liters. Okay, 50 mLs becomes 0.05 liters of solution, and multiply that by my concentration. Okay, but because my concentration is moles per liter, so liters times moles per liter will give me the number of moles. 50 divided by 1,000 times 0.1. 0.0050 moles. Okay, 0.0050 moles of HCl. What else we got in there? So before we mix them together, we've got NH4 plus. How much ammonium did we have before we added this HCl? I'm going to do a similar type of a calculation here. 100 mLs. I'm going to divide by 1,000 to convert that into liters, and then multiply that by 0.100 molar. So 100 is divided by 1,000 times 0.1, 0.0100. And ammonia in that buffer solution, in that same 100 ml buffer solution, it is 0.400 molar of the ammonia. So 100 divided by 1,000 times 0.4, 0.0400. Okay, and so this can be weird to think about, but what's going to happen is when this strong acid goes into the solution, it's going to destroy 0.0050 moles of the ammonia. Not really destroy, but convert it into ammonium. Okay, so let's see. So this was before they mixed. Now let's say after they mix. So let's do ammonia here first. NH3, number of moles 0.0400 moles minus 0.0050 350. 0.0350 moles of ammonia. Okay, that's how much survived the interaction with the acid, with the strong acid. And then the same amount in NH4 plus Okay, and in doing this process, the acid's all gone now. It's all been reacted with ammonia. We've decreased the amount of ammonia in solution, and we've increased the amount of ammonium. All right, what's the last thing that we need to do here? We need concentrations in order to do these types of calculation. And so this is in, these moles are in now 150 mLs of solution. 50 plus 100 gives me 150. So concentration of ammonia Okay, I'm going to go ahead in my head and make that into liters by dividing by 1,000. Okay, now I have a molarity of the ammonia. I'm going to do the same thing here with the ammonium. Yeah. All right, now we're ready for that Henderson-Hasselbalch equation again. pKa plus log of ammonia over ammonium .62. Okay, and if you remember from our previous calculation, or you look back, the pH of the buffer solution was 9.85. After adding 50 mLs of this 0.1 molar HCl, we've only moved the pH by 0.2 units.